welcome back there, boys and girls. Today we're going to be talking about Introduction to Summary Statistics. Statistics is a collection, evaluation, interpretation of data. Statistical analysis of measurements can help verify the quality of a design or process. So a lot of times they'll use statistics to say, okay, we need to work on this, or we don't need to work on this, or we need to fix this. But the stats are used quite often with a design. Okay, some keywords here. Central tendency is the center of a distribution. This could mean mean, median, or mode. All of these are central tendencies. All right, all three of these are ones you've been calculating for several years, but all three of these are considered central tendencies. A variation is the spread of values around the center. This could be a range, a standard deviation, or an interquartile range. A distribution. Distribution is could be like frequency tables, histograms, or a normal distribution. But it's a summary of the frequency of the values. Okay, the first central tendency we're going to talk about here is average. This is the equation. Let me tell you what this means here. This up here, this simply means the sum of the values. Xi meaning x each individual value. So we're going to take the sum of those, and that's what this is called, a little summation. And then it says divide it by the number. Well, what is the mean? It is the average. You've been finding average for several years. Hopefully that's not hard for you. Here's the equation here with the little mu. All right, the mu, which just is exactly the same as the micro, means mean. Xi is the individual data value. The sum of this means we're going to add up all the data values, and n is the number of data values in the data set. Here's an example of this. All they're doing here is showing you that they've added all these values up, and they came up with a sum of 243. They added all, this means add all the values up, and that came up to 243. Then from there, they said we got to divide it by the number of values. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them, so they divided by 11. This right here would be the mean. That is the average. Okay, a note about rounding in statistics. General rule, do not round until the final answer. When you do get done with your final answer, round to one more decimal place than the original data. Standard deviation, round to one more decimal place than the original data. So for the mean, notice each of these here, all right, none of them had any decimal places. They were all point nothing. So their final answer is they went to 22.1, right, because that's one more decimal place. If they had rounded to the same decimal place, they would have just left at 22. But because none of these had decimal points, they made their final answer have one decimal point. Mode. Mode is the one that happens the most often. All right, mode is the one that happens most often. Typically, what we'll do here is put these in chronological order, from least to greatest, or you could do it from greatest to least. Now that we've got them in order from least to greatest, it's pretty easy that you can see then that the one that occurs the most often is 21. So the mode is the one that occurs the most. Okay, here's some other examples of mode. Here the first one they give to us has just got one mode. The second example is what we call bimodal, because it's got two modes, 63 and 59 both occur twice. And then the last one, because it has 63, 59, and 48, it's what we call multimodal, because it's got multiple modes, more than just one, more than just two. Okay, the next thing we're going to find here is the median. The median is the value that occurs in the middle of the set of data that has been arranged in numerical order. The symbol is X with a little squiggly above it. That's pronounced X tilde, where the tilde is making reference to that little squiggle above it. To find the median, we typically want to take this and put it in order. All right, so here's our from chronological order, and it's not, you don't have to do from least to greatest, but typically what we do then is you just simply start crossing them off. We got, here we go. Just cross them off from opposite ends. And when you do that, the number you're left with in the middle is your median. And notice the little tilde there, all right, that tilde is what means median. All right, the median is the one in the middle. Well, how about times when you cross them all off, and when you get to the middle, you've got two of them, 21 and 23. Well, we take the average. You just add the two numbers and divide by 2. So in this case, they've taken the median, which is x tilde, 21 plus 23, the two numbers in the middle, divided by 2, and you get 22. Range. Well, again, put the numbers in order from least to greatest. Once you have them the range is just simply your largest value, which is 44, minus the smallest one. All right. 44 minus 3 means there's a range of 41 from our largest number to our smallest. And that's all range means. Okay, standard deviation. This is one we use quite a bit. It's the measure of the data variation. A larger standard deviation indicates a wider spread in data values. Well, here's the equation. Well, let's go back to what we learned earlier. This little symbol right here means take the sum. This little symbol right here means all the data values. That one right there meant mean. All right, so we're going to take each value and subtract the mean from it. We're then going to square it. We're then going to add up all those numbers, and we're going to divide by the size of the population. This right here is our steps. All right, this is exactly what I just said. All right, so if I was you, notice that I'm highlighting it for you. I would go through there and do something that allows you to be able to find this quickly and easily, that this is the standard deviation, because you're going to have to do this on the test. It's going to be required knowledge for you. You'll have to do it on your ECA, but this is something there's no way getting around. All right, we'll do this quite a bit here. Again, general rule, standard deviation, round to one more decimal place than the original data. All right, you guys keep asking me about rounding. If you notice here, it's always round to one more decimal place than what the original data was. All right, this table obviously is not in your notes, so I'm going to want you to add this table. So go ahead and pause it and add this table. What this table does here now is this allows us to be able to write our data in here. And we'll go through this several times in the process. X, well, I'm going to start putting my numbers in here. This is just my numbers. 2, 5, 48, 49, 55, 58, 59, 60, 62, 63, and 63. Okay, there's our numbers, all right? Well, what was our first step? Our first step was to calculate the mean. That's what this part right here is. We've got to calculate that mean. All right, so we've got to find that mean first. That means I'm going to add all these numbers up and divide by 11. Well, what I've done here now is I've rounded it off to 47.6. None of these numbers have decimal places, so I've gone to one more decimal place. So that's my first step. I got to find the mean. The second step, subtract the mean from each value and then square each difference. So let's do this first part of this. Subtract the mean from each value. Okay, what I'm doing here now is I'm subtracting the mean. 62 minus that. Well, what's nice is once I start seeing a pattern here, all right, I saw 1.4, then 55 was 6 more, and this was 7.4. So what I started doing here then is this is 3 more, so I added 3 to it. This is 1 more, added 1. 60 is 1 more than 59, so I added 1 more. 62 is 2 more, so I'm going to make it 14.4, 15.4, and 15.4. So those are ways you can speed some of this up. It says then square each difference. So I'm going to go in here, I'm going to say negative 45.6 times negative 45.6. Okay, what I've been doing here is I just took 11.4 times 11.4, 12.4 times 12.4, 14.4 times 14.4, or in this case 15.4 times 15.4 is 237.2, which means that's exactly the same. Now our next step, it says to sum all the square differences. So I'm just going to start adding this whole last row and write my sum down here. So then, that's my sum down there, 5,025. I lucked out. I don't have any decimals on the end of it. I may have hit something wrong in my haste. I apologize if I did. But the next step then tells us to divide the summation, that's what I have, by the size of the population. That's n. So right here, I'm going to take my sum, right here, 5,025. I'm going to divide it by the total. That's 11. So that right there then becomes 456.8, and then the next step here says calculate the square root. So now I'm just going to simply hit the square root button, and that right there becomes my standard deviation. My standard Deviation. Well, hey, that's how we do standard deviation. I'll catch you guys on the flip side.